Thank you for joining me. I know it's 4 o'clock on a Friday. That's probably more faces than I expected to see wanting to hear about TDD at that time on a Friday, so good start. Cool, okay, so let's start with a little bit about me. There I am, I'm in the cloud apparently. I used to write C#, that's not really relevant except it makes it sound like I can do more than one thing. I've been doing Android for about 10 years now, and about 7 of those at Moonpig, so I've been there for a little while. And that's my Twitter. If you want to tweet me afterwards and tell me that I'm wrong about everything, that's fine. So I've been to some talks where people have said, like, yeah, automation's my middle name. And I'd love to tell you that TDD is my middle name, but TDD is not my middle name. I don't actually have a middle name. I'm the third child. My parents ran out of names by that point. Both of my older siblings have middle names. I didn't get one. They obviously didn't love me that much. But it turns out if you just kind of write my name like this, and then we just sort of do this a little bit, then yeah, actually, maybe my parents were kind of visionaries after all. All right, so we are going to talk about TDD today. First of all, just some things that I believe which add a bit of context to why I think this is an important topic. So one of the advantages of being at Moonpig for quite a long time is that I've come to spend maybe more time thinking about team practices and ways of working, and kind of zooming out a bit and thinking about our architecture more over a longer period, rather than being like right down in the details of writing features every day. And one of the things that I've come to realize is that practices that you do should serve the team and not the other way around. So you shouldn't be doing things just because someone says you should or because it makes your manager happy. Everything that you do should add value to what you're doing, and they should also help to build shared values within your team. And for me, TDD has helped us do that at Moonpig. I also think that absolute rules are pretty much not very useful. I'm going to say a lot of things where I say you should do this and you should do that. You can ignore me. There's exceptions to all of these things. There's different ways to do TDD. It depends on your project. It depends what you're building. It depends on the people that you're working with. So roughly what we're going to go over, we're going to have a quick look at what TDD is, why you might want to do it. We're going to have a look at how you can get started with it if you've never done it before. A few like common misunderstandings that I see, well, I would say I see other people do. To be honest, a lot of them are things that I used to believe. And then I realized that I wasn't quite getting it right. We're going to look at why TDD is particularly difficult when you try to apply it to big systems, like an Android app, for example. And then we're going to have a look at how you can build an architecture that's designed to support test driving your code. And then finally, a little sample of double loop TDD, which was a approach that we kind of unlocked by building our architecture in a way to support this. Some things I'm not going to do. I'm not going to justify testing. I assume everyone in this room kind of thinks that testing is valuable. I'm not going to explain how to unit test. I'm not going to explain like mocking frameworks or any of that stuff. I'm not going to show you very much code today, to be quite honest. It's much more about approaches and patterns. I'm not going to explain a whole architecture. I will show a couple of architecture diagrams. We use a relatively common MVI style pattern. If you've used MVI or MVVM, you should be able to get your head around it fine. Also, I'm not going to be offended if you just get up and leave in the middle of it. It's totally fine. It's your time. Feel free. So what is TDD? Let's do the basics. You've probably all seen this before. So 3 basic steps. You're going to write a test. It's going to fail, either because it doesn't compile or because it doesn't pass. Then you're going to write the simplest code that you can to turn that test green. And then the third stage that sometimes gets forgotten is then you're going to look at your code and you're going to improve it. Because if you wrote the simplest code that you could to make it pass, it's probably not the best code. That's it in a nutshell, right? There isn't a lot more to say about what's TDD. And sometimes the problem with it can be is it sounds really simple. And then you try to do it and you kind of sit there going, but what test do I write? But what failing test do I write? So we'll dig into some of those steps a little bit later. Why TDD is quite a good question. We'll also look at, there's some misconceptions around this, I think. Here are the advantages that I think it has. Firstly, I don't know about anyone else. I think writing tests is boring. Like, I don't come to work and go, can't wait to write some tests today. Really excited for unit testing. So if you write the tests at the end, you're much more likely to be lazy about it and go like, I'll just write the minimum number of tests I can get away with to get this PR merged in. So if it's the bit that doesn't, in and of itself, bring joy to your life, do it first and get some actual value out of it. What is that value? Faster feedback. That's kind of the intuitive, obvious bit of test driving your code, is that you get feedback as soon as you've written a piece of code as to whether that's working or not, because you can just run the test again and see. More subtly, it also provides structure. It's a structured process, which therefore provides discipline to the way that you work. So if you're in a team where maybe you don't always write tests, saying like, we're going to use TDD means you will now always have tests around it. So it can build discipline into your process without having to kind of build that discipline yourself, right? The process itself builds the discipline. It's very aligned with working in a kind of lean way. So because you have to split your work down into pieces that you can test, small pieces that you can test, that means that it's kind of the same as breaking your features up. So it starts to build this mindset of, how can we break this down into a small piece of code that I can write, test, make sure it works, and potentially merge and ship to a customer. And it also promotes simple design, because simple code is easier to test. And so if your code's easier to test, TDD gets easier. And if you do TDD more, you'll find the pain points where it's not easy to test, and then you'll be motivated to improve your code and your architecture, which is what we're going to talk about later. Cool. So where should we get started with TDD? Katas are a great place to start. So katas are like little coding challenges. You can find loads of them online. You can just Google them. There's websites full of them. There's a few examples here of some that are really good for getting started with TDD. You basically want simple problems that are one function, very pure, no state. You can just like put an input in and test that your output comes out properly. I would recommend when you're working on these, like, go slowly, right? You're not like, your product manager probably doesn't care when you finish the kata, so it's fine, just work slowly. Do a lot of thinking. If you can find like a pair or a group to work with, especially if you have like that one person at work who won't stop talking about TDD, go and tell them that you want to do TDD katas with them, because they probably spend their life trying to get people to do it, and they'll get very excited and they'll spend their lunch break with you. And when you finish a kata, like, do it in a time box is a nice way. Give yourself an hour or something. And when you finish it, stop and reflect on what you did. It's quite nice to restart the same one again, right? Do the same one over and over again and use the information you got from the first time you did it to see, like, what if we start with a different test? What if we start with a smaller test or a bigger test? Moving to real software is quite a difficult jump. If you try to just go, I'm going to test my whole Android app because now I've TDD'd Roman numerals, I'm an expert, you'll probably immediately get stuck. Most likely I realize it keeps going blue, it's the connection, but we'll put up with it. Most likely your architecture is maybe not that well set up to testing, or you're just not used to TDDing on that kind of scale. The first piece of code I ever TDD'd in practice was the Loon algorithm. Loon algorithm is basically the check digit on a credit card. I stole that picture from the Monzo website, but I'm allowed because my wife works for Monzo, and that means I own half of everything that she has, right? Okay. Don't tell Monzo I stole it, please. So yeah, the Loon algorithm is that check digit. It's a really simple algorithm. You can look it up online. It's well defined. That was a really nice piece, and it just like sat in our domain, and I TDD'd that out. But I definitely couldn't, at that point, TDD the whole app. That wasn't within my capabilities. And then I kind of got stuck. I was like, I can TDD domain logic, and I don't know where to go from here. So let's look at some of the things that, on reflection, I realized were holding me back, things that I didn't quite understand at that point. TDD is a way to write better tests, or one that you find a lot on articles online. If you go and Google like advantages of TDD, massive like Google results, just click on one of them, and you'll find things like, oh, it's great because you get a great test suite and then it reduces your bugs. It's like, no, hang on, that's an advantage of testing, right? That's not an advantage of test driving. So this is quite common, and to me it misses the point, right? So firstly, like writing tests isn't TDD. I think that's kind of reasonably clear. I could just write the test afterwards. You can argue maybe you can't quite write the same test afterwards, but you broadly can. Back in the days where I didn't really like TDD very much, my manager wanted me to do it, so I used to say that I'd TDD something, but I didn't, and then I'd put the PR up, and then he'd merge it, and then I'd go, you didn't notice. Not my current manager, I should add, but yeah, right? So I honestly think you can write mostly the same tests afterwards. That's not the point. The primary output of TDD is the software itself. The tests are a byproduct. They're there to help you during the process, and the fact that afterwards you've got them, bonus, right? Yeah, they are going to be useful and valuable in the future, but that's not the reason you do it. TDD involves less thinking, or with TDD, the code writes itself. Okay, no code writes itself. Like, I don't know. Or there's that thing on GitHub now, right, where the code writes itself, but that apparently is just going to get you sued, so you probably don't want to use that. The code will not write itself. You are going to write the code. Whether it involves less thinking, it depends. It depends on all kinds of things about your team, about how experienced you are with TDD, about the rest of your architecture. What it does do is it kind of shifts thinking in your process and in your system. So instead of asking what code should I write next, you're spending more time thinking what test should I write next. So that means that your thinking is happening while your system's in a stable state, right? You're green, if you like, in that green-red. So that means if you get distracted or stop thinking, your system's good, right? You're not thinking as much while you're writing the code. Of course, there's still some. The other thing is it shifts thinking out of your feature work, because if you take the steps to make your system more testable, you can front load a lot of the complexity and work onto your architecture and your system design that you don't need to then repeat in every single ticket. And if you have like a platform team or even just like more experienced engineers in your team, like they can take on that work, and it becomes much easier for like your less experienced engineers to write like nicely tested features without having to deal with the complexity. So it seems like maybe there's a problem with test-driven development. Like, maybe it has the wrong name, because it's not really about testing. It's really about development. So the fact that the word test comes first often like makes people think it's all about testing. But also, like, I feel like maybe driven isn't a good word either, right? Like, if you need to visit your friend and you get in the car and you don't know exactly where you're going and you use a map, and someone says, like, how did you get here? You don't say, yeah, the map drove me here, right? The map guided you here. So I would say development guided by tests, maybe? That might be a better way of wording it. Someone wrote a book on it. So it turns out I'm not maybe the first person to think that, or maybe I just stole it from the book. You can decide for yourself. So yeah, another couple. TDD is faster. Again, it just depends, right? Like faster than what? Is it faster than bashing out a feature? No. Is it faster in the long run? Maybe. Are you good at it? Are you experienced with it? Ultimately, like TDD is not a speed. It is not a methodology designed for speed. It is a methodology designed for quality, and that's what you should be focusing on. And finally, the refactoring step. Often people think that that's about like fixing other people's old code that you found in the system. In general, that's kind of how we think about refactoring. Refactoring in TDD means looking at the code that you just wrote right now and improving it while it's still in your head, right? While the context is fresh and you understand how it fits into the system. Don't make the person come back to it in a year and look at it and go like, why does it look like that, right? That's not what you want. But TDD doesn't define that quality. That's the thing you have to do separately, right? What is better that's not answered by TDD. I am going to keep calling it TDD even though I think it's a bad name because it's just an easy acronym to say and everyone knows what it means. Okay, so we've kind of TDD out some katas. Maybe you've written some logic in your system, but now you're like trying to TDD a whole screen on Android. You know, maybe not quite sure where to start. And you tried testing your activity because there was some code in there. That didn't work out very well, probably. Right? Why is this stuff difficult? So real software unsurprisingly, is complex compared to like katas or small units of code. You're making constant design decisions. You have lots of classes that talk to each other. You have to deal with state management, right? Like a lot of those classes have no state at all. You've got concurrency and threading and networking. You've got side effects and things that are more difficult to test. Real software is also inconsistent. You've got the existing code that someone wrote 3 years ago and then quit and didn't name any of the methods sensibly. You've got existing tests. So if you go in and try to like TDD something that's already tested, it might be that the existing tests aren't very well structured. And you've also got like competing tools and patterns maybe in your architecture. So for example, we currently have some Compose and some XML. We have a lot of RX Java and we're starting to move to coroutines. And often these things require different types of testing. So that can make it difficult to find like one fixed pattern and way of working. Real software has dependencies, right? You have dependencies on your own classes, your own maybe like base classes that your architecture is made out of. You have libraries that you import. You've got your backend that maybe a whole different team is writing. And also just like Android and then the tooling that comes with Android. All of these things add complexity to your system. And often are either difficult to test or in some cases impossible to test. Which leads to this one, right? Real software is not uniformly testable. In my kata, I can probably just test any line of code I want because it's just like some simple Kotlin. Activities and fragments, right? If anyone's tried to do it, you probably like started digging out Roboelectric and then you've had a sad day, right? Like I've definitely had some sad days with Roboelectric. Testing your UI, I mean, Compose is helping a lot here, but it's still generally more complex. Definitely in the old XML world, it's not great. Navigation between screens is difficult because you can do it a bit more with some of the like Jetpack nav stuff. But like our app's old enough that we've never introduced that. So the only way really for us to test navigation is to get an espresso test up on an emulator and start like running through the screens, for example. And all of these have like these magic solutions, right? Like, oh, we'll use espresso or we'll use Roboelectric. And usually they're not that great, right? Usually if you have something that's just inherently hard to test, and then someone builds you a nice framework or a library to make it testable, it probably still sucks. Like, I don't know. Does anyone here like love espresso? Right? No one loves espresso. There we go. Right. Okay. So that's all the reasons why your software is hard to test. How can we make it easier to test? So we can flip those around, right? If we want a TDD-friendly system, we need to make our core architecture and our system as a whole simple, consistent, independent, and testable. So what patterns can we use to get there? So first thing we want to do is we want to make all of the logic in our system testable. So first of all, what do we mean by testable? Okay, let's start with an architecture. That's roughly speaking our MVI. Hopefully it kind of makes sense. Your activity spits out an intent and it bounces through your layers, through your view model. You may or may not have a use case. You might have more than one repository or none, depends on the screen, but like roughly speaking, in a typical screen, something like that. Unidirectional data flow, some kind of network request maybe to an API, and it comes back and it hits your view model, and we take the view state and we reduce our result into our view state and we spit out a new view state. And we emit that back to the activity, and then the activity is going to render it out. Okay, so which bit of our system here would I consider testable? Yeah, all of it could be tested, but like which bit's nice to test? Basically, the bit that you can write a nice JVM test around and run it on your laptop, right, without having to spin up an emulator or anything. So broadly speaking, that green box. Okay, so there are two main bits of logic here that we're going to want to try to move into that green box. One is kind of that area. It's the rendering of the view state onto your UI. If you had Compose, it might be a bit different, but it's still the same thing. You have a view state and it ends up being drawn out to your UI. So we want to try and move as much of that into the green box as possible. And the other one is here, which is a little bit more subtle. So in a lot of MVI implementations that I've seen, the intents get generated in the activity. So there'll be a piece of code, you click on a button that goes, this button fires such and such intent. So what can we do? So we're going to do two things to improve those two bits of our code. We're going to make our view state very expressive. And this can be a little bit weird because it looks like you could get the view state into a strange state where you could have, say, the loading let me show you the properties. So like that's an example of a fairly simple view state. So notice that we have visibilities for, say, the loading spinner and the content block and the error. And I could spit out a view state that has all three of those enabled, right? If I did this with nice like sealed interface and I could have types for each one, now I could like guarantee that I only spit one of them out. That might feel like a better solution. But now I have logic in my activity that's like type checking. So with this, I can like bind them directly onto the properties on the view. And I know I'm not going to spit out a view state that has both loading and content enabled, because the logic that does that is in my view model, and I tested it. Right? I can write tests around that. The other trick that we do here is the retry intention. So all of our intentions are generated in the previous reduction. We call them intentions, like it's just an intent from MVI. We just renamed it because everyone got confused between Android intents and MVI intents. So you can push your intention, instead of being in that little red circle there, it can be in the reducer of the previous view state. So if you look down the bottom there, that's an example of an error coming back from the network, say. And at that point, we build the intention. And what does that mean? Now I can verify that the correct intention is going to fire when that button is clicked without having to deal with the button at all, because I can test it on the previous reduction of the view state. Okay, another thing that we probably want to do is push as much of your gnarly architecture testing down into your architecture tests. Probably reasonably intuitive. So anything that's like the plumbing, how all those classes fit together, anything to do with lifecycle, state management, you're just going to write those once, right? And then every screen's going to use them, so don't make them be tested every single time. Here's an example of like a test. You don't really need to worry about the code, but notice how like up in the top right, we're like mocking a lambda, and then we kind of like verify that that lambda gets called if the view state gets restored from the view handle state, right? This is all like Android state management stuff. This test is down in our base architecture. No one has to care that this works. Everyone can write a screen, and if the app gets backgrounded and the device throws it out of memory, it will just come back, and it will work, and you don't have to test this. So this is one less thing for me to worry about when I'm in that moment going, but what test do I write next? So try to make as much of the public interface of your, I say public, meaning like to your team, of your architecture be pure functions. Pure both in the literal sense of like no side effects, but also like in the sense of simple. So 1 or 2 inputs, 1 output. So like most of our mappers, as we go across like the top there, say the use case, you have like an action goes in and a request goes to the repository. Like that's just like 1 in, 1 out, and it's a straight mapper. Like loads of our code ends up just being when statements, and they just map 1 to 1. Yeah, try not to have state, because that makes it much easier for testing. Like I know that I can do the same thing every time and get the same result. And then all of your tests should be like nice simple assertions. If you need to expose something to a test to be able to unit test it, even though you normally wouldn't because your architecture doesn't require you to do it, I would say expose it. There are people who would disagree with me on this. I would say it's okay to expose something, make it testable in order to make your life easier with testing. So this is an example. In the top left corner, there's this like gnarly code. This is basically the reduction code in our base view model. And you can see that reduce function. So that reduce function is public. But it doesn't need to be public because the base method calls it, right? It's in that code in the top left. That's the only place it gets called anywhere in our app. So by making that public, technically someone could come along and call it directly. But it's like, yeah, but they're not going to do that, right? So by making it public, we can call our reducer directly from our unit tests, and that means I can have just a nice, simple, pure function to test the reductions of our view state. And finally, for these patterns, make your side effects clear. So look for cases where you're using the same side effects repeatedly across different screens, and just make them first-class citizens in your architecture. And then like test that they're plumbed in properly once, and then you don't need to deal with them again. An example, probably the most typical example I would think is tracking or analytics. So like we do tracking on every screen. We want to basically track that the screen showed up, and we want to track all of our intentions from the user. So when the user presses a button or scrolls or whatever. So we just expose a nice interface for this. You can just complete it for your new screen, and it's all plumbed in automatically, and you can basically just assume it works. Okay. Yeah, and in general, prefer consistency to perfection. So it's better to have one architecture that lives everywhere, that's used by every screen in your app and that everyone understands, than have one screen that's this perfect new MVI you've just built, and the rest of it is some like 5 screens are in MVVM, and then there's another 5 that are in MVP, and you've still got those 2 old ones that are in MVC. So we kind of made a decision in like 2018 or so that we built our MVI, and we've just been iterating it on ever since. So no breaking changes allowed, and no one's allowed to call it legacy. So if you make a breaking change to the architecture, you have to go and fix it on every screen in the app. So try to make your breaking changes very small so you can do that in like an hour and then merge it. So a few tips for, I guess, around the like process of TDD. Yeah, only commit on green. So it doesn't have to be like one test. It depends on where you're writing, but like write a test and fix it and then merge it. If you get interrupted on red, then I would suggest you probably like don't commit that and try to come back to it. This just keeps your history really clean. It means anyone can check out any commit, and it will compile. Refactor is a separate commit. This makes it really easy. If you're using pull requests, I mean, I'm a big fan of pairing, and hopefully then you need less reviews. But if you are doing asynchronous reviews especially, pull your refactors out into a separate commit. It just makes it much easier. Don't do this evil TDD thing where you take simply very, very literally. I think it's broadly unhelpful. If you can see the right way to do it straight up, and you know that because you've got 10 screens in the app that already work exactly that way, you don't have to write the dumbest implementation of it the first time around. I think this is something that comes a bit with time. When you first start out with TDD and you're doing katas, I would say like maybe try being stricter with it, but you definitely, like, as I said earlier, right, no absolute rules. So like relax a bit over time, and do what makes sense, right? Don't follow TDD for the sake of it, do it because it's valuable. There we go. So we've now got our nice architecture with all of our logic pushed inside of that green box. And what happens is you start off with the kind of classic approach to TDD of, I'm going to unit test everything, but I'm going to test drive it, which is a great place to start. And that's basically where we started. So let's have a look at how that would look. So first of all, I'm just going to like throw away the UI because I'm just going to say we're not going to test that for now. We will talk about that at the very end. And let's say we want to test drive some logic in our use case. So you probably end up with something like this, right? You have a test that sort of puts the input in and gets the result back out, and your use case is the thing that you're testing, and your repository, you're going to mock it out. And yeah, this works great. And then you go to your view model, and you do the same thing. So now you're mocking out your use case. And then you realize that the mock you just put in your view model test now has to replicate most of the behavior that you actually already wrote in the use case. So you've kind of duplicated logic between your production code and your tests, which is fine. It's just a bit of a waste of time. So, and the same thing happens with the repository, right? The mock here will duplicate a lot of the behavior of the repository. It will be simpler, but there's some duplication there. So what can we do instead? Well, we said that this whole box is testable, right? So what if we said we'll just test the box? So instead of, we'll basically put our test where our activity or your fragment or your compose, whatever pattern you're using over there. But you drop your test in there. And we're obviously still going to mock out our API. And now everything else is real. So if you're bored because I haven't shown you enough code, next four slides are for you. We have some setup that lets you kind of spin up an easy test around this whole block. And we use a lot of Rx, as I said. So this is Rxy. You could do basically the same thing with coroutines. So you have a way to push intents or intentions into your view model, and you have a way to get view states back out. We also have view actions here. View actions are our version of basically like transient view events. So something where you want something to happen on the view, but you don't actually want it in the state. Typically like navigation, because if you put a navigation event in your view state, you go to another screen and then the user hits back, you'll get the same view state back and you'll render it again. So we basically have a kind of stream that comes out on the side of our view state, which emits actions, and they just get consumed once and then they never show up again. So we've got kind of a test setup here that lets us put intents in, and we can get our view states and actions out, and then we can assert against them. So how do we set that up? This is probably the simplest one I could find. But this is, right, that's a real view model with a real use case, with a real repository. And you can see there's a test Apollo. Apollo's a GraphQL library that we use. So we're kind of mocking out the networking. And then we're mocking the tracker, because that's a side effect. We don't want to test that here. But everything else is real code. And then you can just write like little simple tests like this. It looks exactly like a unit test, right? But it's testing your whole system. So we feed one intent in, and then we just assert on the view state. The line that's covered up there is just pulling the view state off or out of the observable. And if you remember that little pattern we talked about earlier where we create our intents on the previous reduction. So this is what that lets you do, which is quite nice. So now in our tests, if I want to test what a button does, I can set up, say, like a network response here, and fire the intent to go and load that, and it's going to emit a view state. And then I'll grab the view state, and I can pull the intent directly off of the view state. So I don't have to generate it in my test. So I've pushed some of the logic like inside that green box, which means I don't have to now duplicate it in my test. I just go like, well, whatever intention is there, just go and get it, and then fire it back in, right? And we'll see what happens. And if it does the wrong thing, I know that my system's not set up properly. I probably didn't create that intention properly. So then that goes back through, and then we just assert as normal. So what this allows you to do is write less tests, which is great because we don't like writing tests. So what happens? You write your acceptance test, and you run it. It probably tells you that your intent doesn't exist yet, right? You've probably said fire this intent in, but you haven't actually gone and created it. So you'll get a nice little error. And the feedback from the test tells you roughly where to look, usually. So I'll go to my seal class, add my new intent. Perfect. Run it again. Probably tells me that the view state I'm asserting on is not there, or the field's missing or something. OK, cool. I'll go and add that. And now, most likely, I'd get some error, something like the intent to action mapper, which is just like a when statement, doesn't have that intent in it because it needs to be exhaustive. So cool, we'll add that little mapper, spit out the right action. And notice, I haven't written any unit tests here, right? I didn't need them. Every piece of feedback it gave me was so simple and directed that I can just go to that one place in the code, fix it. It's usually a couple of lines of code, and just run my main acceptance test again. Same thing with use case. So I'm going to, at this point, I'm going to call out to my repository. And maybe here, actually the error you get doesn't help very much. You kind of look at it and you go like, you go to your repository and you write your code and you return something and your test still fails. And you go, okay, I'm not sure what's going on now. What do I do? Do I start debugging? Well, you don't need to, right? Because you have another level. So we'll just drop down. So we'll drop down and we'll say, I want to test my repository. I want to get more feedback here. I want more detailed testing around this. So I'll swap my use case out for a test, and I'll write a unit test down at this level, and then it will probably tell me, oh, you didn't map the whatever back from the service, and you go, oh, yeah, of course. And then you fill it in, and then your test goes green. And now we can jump back up to this level and rerun the acceptance test again. And the process continues, and maybe you get some feedback over in the reducer, and you can do the same thing again. And what we found using this was that you could drive most of your code using only these big loop acceptance tests, and you just drop down when it's valuable and when you need that extra level of feedback. Most often, I would say, the repository mapping between the service and the domain model and the reducer. Those are the two places where I generally find it's most valuable to go in and add some unit tests, because those are the places where there's like most of the actual logic going on. And then eventually your acceptance test goes green. And depending on what your test was, you can almost certainly make a commit now. You can maybe do a bit of refactoring afterwards, and then you can merge it, you can ship it. Maybe you can't, maybe you need another 2 or 3 acceptance tests to get to that point. But broadly speaking, this is now a working piece of code. So you might be wondering, like, how does this fit in with, I said earlier, like, we'll talk about the UI later, and I don't like espresso. It's like, sure, but there's still some code there, right? Like, there's still some binding there, even if it's not much of my own code. Or if you've got a recycler view, you're still going to have some code down in there that like maps your types around. Yeah, for sure. So we do still use espresso, and the way that we decide like what to test is by kind of like, how bad would it be if this was broken? So espresso is for, the app would be completely fundamentally broken if this didn't work. So for us, that means critical journeys. So we're basically an e-commerce website, an app, obviously. And so for us, that means like arrive, pick your card, customize your card, add your favorite flowers, tell us where it's going, tell us how you're going to pay, check out. That's our core journey. We keep espresso tests around that. We have I think about 15 or so espresso tests in the whole app. We very rarely touch them. Sometimes you just need to like tweak them a bit because you changed the screen. We're even rarer that we add more, because really that critical journey doesn't change or grow very much, which is great because I don't want to touch espresso tests basically ever. Acceptance tests are for, the customer would be unhappy if this was broken. So these are for like all of our features. This is your almost all of our code. So we will acceptance test everything within those critical journeys as well as we build it out. But if we had a screen on the side that we have a screen that lets you add like reminders for people's birthdays and anniversaries and things like that. Right? It's kind of important. Users might leave us a bad review, but it doesn't stop them buying something. So we wouldn't espresso test that. We would just use the like double loop process. If it's something where just the businesses would be unhappy, we'll just unit test it. Don't bother with the acceptance stuff. So usually that's like side effects like analytics. We'll just unit test those. It gives us a little bit of safety, but if it's broken, we'll just go in and fix it. And we're only allowed to leave something untested if it would only make us unhappy. So that's stuff like debug code, logging. I mean, you presumably aren't shipping that anyway, so it's fine. You can just not test it. That is basically all I have to say. I didn't even write like a wrap-up slide, but basically, yeah, go out, write some tests, and have fun.